Hey everyone, for those of you who don't know me, I'm Arie de Jong from Think Parametric. Today, we're going to dive into something really exciting. We're going to model BIC's IQON Building in Quito, located in Ecuador. By the end of this exercise, you'll know exactly how to take a complex building design and turn it into a parametric model using Rhino and Grasshopper. Now let's jump right in. So, what are we going to learn in this exercise? Here's what we'll be guiding you through. First, we'll analyze the key features of the IQON building, things like the jagged balconies and unique facade shapes. This is super important because it'll help you understand the architectural logic behind the design. By doing this, you'll get a solid grasp on why certain forms are used and how they interact, which will set you up for modeling complex buildings effectively. Next, we'll create the base curves in Rhino, including the unique curved sections of the facade. Getting these foundational curves right is crucial because it makes everything else much easier. With an accurate base, the whole modeling process becomes smoother and you'll keep everything aligned. After that, we'll break the facade into staggered sections that move diagonally up each level. This will help us replicate those striking diagonal lines that are a big part of the IQON's building's look. Plus, you'll learn how to use Grasshopper to create a pattern that you can adapt for other projects, saving you time and adding complexity when needed. We'll also generate the jagged facade lines by weaving offset points along the building's face. This gives the facade the stepped, dynamic look for the balconies. By the end of this part, you'll be able to create intricate facade details that can easily adapt to changes in your design. Finally, we'll turn those facade outlines into solid 3D volumes. This is where your model really comes to life in 3 dimensions, making it ready for detailing or visualization. By the end, you'll have a complete 3D model of the IQON building that you can use or refine further. If you want to follow along, you can download all the files from our asset vault. There's a link in the description below. And if you find any of this challenging, no worries. We also have a free introductory course on Rhino and Grasshopper that you can check out. Alright, let's get into the technical part of the tutorial. Remember, if you're interested in going deeper, we cover a lot of these concepts in more detail in our Grasshopper certification course. Now let's get started. Here are some photos from the building we're going to try to deconstruct. And as you can see, there's some pretty interesting things going on, specifically the facade elements that kind of rotate a certain way, creating this spacing for balconies to occur in this jagged way it happens. So let's see if we can deconstruct this a little bit better for us to be able to set up a definition. I think the first thing we can see, I think specifically here, or we can go to a floor plan. If you follow the outline of the facade, you have a part that's straight until a certain point, and then you see when it reaches the end of the building, also where the facade kind of even opens up more, where these balconies start occurring, you see that the facade kind of has this fillet where it like around to the other side basically. And I think if we go to a floor plan, we can see it even better if you scroll all the way down. I'll share this link in the description of the website, or you can just Google IQON Building with a Q. If I open a floor plan of the building, here you can see it even better, right? So we have, a part that's straight to a certain point, and then it like kind of fillets around the corner, right? So that's one thing we have to set up in our definition. And the way I'm thinking of doing it is to create this curve in Rhino. That's the only thing we're going to draw in Rhino, and have that curve basically drive the whole facade. So another thing that is happening, if I go to, I think here I can show it the best, like the kind of the side view, is that the first thing that you're seeing is that if we imagine that curved line I just drew, based on that line, you have this jagged like facade setbacks going on, right? And they get less and less the more you get to this line where it basically becomes straight. That's another thing you have to keep in mind, how to create this jagged curve based off of the facade curve. And another thing, which is very interesting as well, is that we have these diagonals going on. So that's a very nice pattern in the facade that creates this really nice aesthetic, right? So that's also something we want to recreate, right? These lines basically. And that's happening because of the different position of the first facade element. If I show it to you a little bit better, if you go to the front view of the building, to this one, if you look at this side, you see basically there's a repetition every 3 floors, right? So we have this first element, right? Then the next element is kind of shifted a little bit to the right. And then the third one is even shifted more. And then it repeats again. So, this first element is again here. And the second one is shifted back a little, etc., etc. And, all these things, if you add them all together, it creates this triangular, lines in the facade. I think those are the main things we have to take into account. And we're going to set up the definition. So yeah, let's get to Rhino and let's start creating our grasshopper definition. So the first thing we're going to do is set up some base geometry in Rhino. That geometry will kind of guide how our definition is going to work. And you can either follow along, start from scratch with me, or you can open the definition which is included in the description from this video from our asset vault. That input geometry will be 2 curves. Let's draw them quickly in Rhino. So to just be 2 line segments. And instead of using a fillet between those line segments, we're going to use the blend curve component, so we have a bit more liberty. Just like this. And as you see in Rhino, one of the curves has to be flipped. So let's flip this thing in Rhino. And we need to also specify a bulge vector. So let's insert 2 sliders. And so we can control that bulge a little bit better. Also the continuity, either you can use tangency or curvature, depending on what gives you the best fillet. For now, let's just leave it like this, is fine. This is our base curve that's going to drive the whole facade. And then I want to extrude it up and then slice it at the right floor heights. And for that, we need to set up some floor heights. We're going to do that also dynamically by specifying some functions and what the floor heights are for those functions, and then how many functions I want. So we need 2 panels for that. And this one would be the floor-to-floor height in meters. And then this would be a number of floors per function. So let's say we have a lobby, which is 6 meters high. Let's say we have apartments, which are, let's say, 3.5. And we have some office as well, let's say 4.5. And don't forget to set it to multi-line data. And now we're going to specify how many floors we want from those functions. So let's say, our first floor would be the lobby. So we need 1 floor of that. Let's say we have 5 floors of office. Then we have some apartments, let's say 10. And then all the way on the top, we have another lobby. Or let's say we have 2 floors of lobby, why not? Now we're going to use these 2 lists basically to create our floor-to-floor heights. And there's a very nice component in Grasshopper that does more or less that, which is under the sets and then under sequence and then stack data. Now, before we can insert information here, we need to separate this list and clean it up a little bit. So we have the functions and the actual numbers. So for that, we need to split this text. And if you go to the Sets tab, again, under Text, there's a component called Text Split. And as you might have guessed, for separates, we're going to use the colon. So we can just use a panel for that. Just in case, we're going to trim the white spaces on either end. So there's a component here, also in the text, called Text Trim. And it does exactly that. You can leave the start and end with your Boolean values to true, because you want to trim at both ends. And then we have to use a component called Find Similar, which will find a member in a set. And let's get our individual items. So we have supposedly 2 items, the text and the number. Just like this. We can set this one. We can flatten this list. This one as well. Excuse me, we need to flatten these outputs. So we have a list of, the list of functions and then their number, how much we want. This is needed so we have the right function in the right order, because here the order doesn't really matter. I could put apartment in top or lobby in the bottom, but here the order does matter. Like this will be the order we're going to build up our floors. So first the lobby, then the offices, then the apartment, then again lobby. And this component makes sure that we get the right data. So this is the data we want to stack. These are how many floors do we want. So this one goes in stack. And then supposedly here, if I show you with a panel, we have all our floors right now stacked. So we first have a floor that's 6 meters, which is the lobby. Then suppose we have 5 of 4.5, and then 10 of 3.5, and then again another 2, which is again the lobby of 6. So these are floor to floor heights. And then I'm going to insert the ground floor manually using list insert. And the indices would be 0 because we're going to insert it in the beginning. And then the item we want to insert, let's use a point so it's more dynamic. So let me insert a point and let's link it into Grasshopper. I'm just going to put it at 0, 0 for now. So this would be the starting point. And this would be facade curves, input curves better. And then I'm going to get the Z value from that point. And that's the one I'm going to insert in my list in the end, just like this. So now we have our whole list, but we need to get that list floor to floor heights to actual level heights. And there's a nice component called mass addition, which adds all those numbers together. So the building would be, if I hover over result, 75.5 meters high. But I'm more interested in the partial results. And this list will nicely give me all the levels. So let's join these curves together, because now this one only gives us the blended curve part. So let's use a join curves. And this one goes in here. Hold your shift to insert multiple. And just in case, flatten this input. So we have one curve. And I want to extrude this curve, so extrude. And then direction would be the Z direction. And how much, we can use the result input for that. So now we have our, as you can see in our Rhino viewport, our facade, basically our facade surface, our guide surface. And that's our surface we're going to be using to base our staggered facade elements on. So we're going to slice this surface using the contour component, the contour X. So the shape would be our extrusion, and our plane, the XY plane, that's fine, the default. So as you can see now, we have all our facade curves, right? So we have one level of lobby, as you can see, which is 6 meters, then 1, 2, 3, 4, 5 of office. Is that correct? Did I put 5? Ah, yeah, I put 5 office, yeah. So 1, 2, 3, 4, 5, and those are 4.5 meters high, right? And then missing are 10 levels of apartments all the way until here, right? And then the top ones, these two are again 6, because the lobby, remember, is 6 meters high. So we have this division right now. So all the floor lines are at their correct levels. Let me just turn everything off. So these are our contours. Let me simplify the output, because what I wanted to put is, again, a number. So we know, like, these are important numbers, which are these guys. And these are the floor levels, or, floor outlines better. And don't forget that the last one is the roof. It's not technically a floor. What we can already do is directly put that roof in another branch. Instead of flattening this list and just popping it off, let's use a mask. Split tree. So data would be these guys. And then I want to, separate the last branch. So there's 18 branches or 19 branches, last one being 18. So I need to subtract 1 from here. So now it should say 18. Convert this thing into a path. And now we have in the positive, if I go to the curve, you see that, the top one, that's the roof. Call this one roof. And all the other ones, negative, those are like the floor, our floors. Basically, we're going to be working with those ones. Okay, guys, so now we have set up our definition. And the nice thing is that everything is dynamic, so I can move this curve up, and you see that, the building also starts slicing somewhere else. We have our start point, so which is dynamic. We can change these numbers here. Let's say I want to have 2 levels of lobby, then I want another lobby here in the middle, maybe 2 levels or something like that, and in the top just 1, something like this. You see that, the whole thing changed according to my inputs here. I can also change the heights. Let's say I want to change this one to 8 or whatever. So you see my offices right now, 8 meters floor to floor. So this is a very dynamic way, very quick way to set up building slicer, basically. So the next step is to divide the facade in different bays that are staggered, and they diagonally move up every level. So let me show you what we're going to do right now. So the idea is that we're going to divide the curves with a preset distance. And then the next one, as you saw in the photos, is slightly shift. So we need to offset this a little bit and then apply the same distance. And then the third one would be again shifted just a little bit. And then the fourth one again would be shifted back all the way to the beginning like this one. So we start again with the same one. And then the next point supposedly should line up with this diagonal line, right? If you apply the same distances again and so forth. So all the way to the top. So the next one would be line up with this one. So it would be here. This one would be, somewhere here, etc., right? And then, continuing upwards for all the curves in the facade. So now the way we're going to do that is using a component. It's under the curve tab under analysis. And there's a couple of ones that we can use. One of them would be evaluate at a certain parameter of the curve. But I think it's a bit better and better understandable for us to use the evaluate length, at which we can use evaluate a curve at a specific length, which is specified in meters or the units we have right now. And if I use that component just to show you, let's set this thing to false because we don't want it to be normalized between 0 and 1. We want to use the actual length. And let's just use a slider so I can show to you. So this is the idea that we start and then we specify at a certain length, let's say 8 meters, which we're going to use for our base, and then continuing this number. So at 8, at 16, etc. And there's one thing I notice right now is that, the bottom curve is flipped right now because all of them start at this side except this one here. And I think it's because we cut the surface exactly at the edge. So we have to, first of all, make all the curves face the same direction. And then I want all the curves, instead of starting at this side, I want them to start at this side. We're going to use the flip curve component. And then we're going to use a guide curve, which is one of these guys. And just going to flatten this list. And instead of using the first one, which is the one that's kind of off, I'm going to use the second one as the guide curve. Just like this. And then let's see if it works. Nice. So now at least all of them are aligned the same direction. But the problem is I want them to start from this side, so I have to flip them again. So let's use the flip curve. So let's create those list of numbers so they get this staggered effect. So I'm going to move this component a little bit to the right because we're going to first create some lists. So let's start with 8 as our base value. And then we have to create 3 offsets because that repeats every third level. The first offset would be 0. Then the second offset, I'm going to use 1/3 of our value that we're going to insert. Right now it's 8. So I'm going to multiply this value by 1/3. And then the last value would be at 2/3. So it's like this. And I'm also going to multiply our initial value with that. So we have our 3 offsets, and I'm going to merge them together in a merge component, just like this. And then we're going to get the 3 statistics because I want to know how many times I need to create this value list, and that's the amount of curves there are. These are our curves. And if you look at count, we see that we have 18 curves right now. So I'm going to repeat that data. So first of all, our regular number. And then our list of offsets, just like this. So if I show to you you have just a list of 8s, 18 8s right now. And this guy is just our offsets repeated every 0, 2.6, 5.3, 0, and then it starts again. Then I want to have this data to have the same data structure as our curve. And there's a nice component called unflatten tree, which does exactly that. So the tree we want to unflatten, which is this guy. And then this is the guide tree we want to have the same data structure as. The same for these guys. So all I did was put everything in its own branch, all the values. And then we just have to duplicate this value a lot. So we can use repeat data again. I think that's fine. We don't know exactly how long the curve is, so we're just going to duplicate it with a lot of, or repeat that data with, let's say 100, a big number. And then we're going to insert these items in the beginning of this list. Items would be these guys, and then in these 0. So right now we have our first list. So start at 0, and then we have 8, which is our common dimension. And then the next one should be the offset, if I can find it. So it's 2.6. And then the second one would be the 5.3, and then 888 again. And then the third one should again start at 0, just like this. And then we're going to use the same technique as we used with the floor-to-floor heights, using the mass addition component, just like this. And then, of course, we're going to be concerned with the partial results. And this is the result right now. And that's exactly what we were after, right? So, the beginning at 0, then we have a slight offset, and then again at 0. And then our common number is 8, our bay length. But of course, we can, increase this factor. So the whole definition is dynamically set up. And the only thing that we need to fine tune a little bit is the ending. Because of course, like in the beginning, as you recognize from the photos, we have the base actually having a small offset. But on the other side, they need to end exactly at the end. And there's some numbers that are a bit too close, so the base get a bit too tiny, and I want to be able to control that. So let's take a look into that as well. And to be able to do that, right now we do need to convert our points to parameters on the curve. It's a bit more easy to manage like the culling of the ending of the points. So there's a nice way to do that using the curve closest point. These would be our curves, and then we need to reparameterize this curve. So it's between 0 and 1. This is our original curves. And I'm not interested in the point, but I'm interested in the parameters. And first I want to clean out a lot of the parameters, because we put, like, as you remember, 100. But of course, there's not that many, depending how long this curve is. So there's only 9, that's great. And then I want to test if this number is above a certain number, and then kill it out if needed. We're going to use an expression for that. And the expression would be if x is smaller than y, I want to output 1, and then if not 0, which is going to be our culling factor. The top one should be x and the bottom one y. Simple number slider from 0 to 1. Let's say 95 for now. And then we're going to use a cull pattern component, just like this. So this makes sure that we cull out points that are a bit too close to the ending, depending if it's above this parameter value, the 0.95. And then in the end, I also want to insert like the last point on this curve, which is going to be at, if the beginning is 0, this is going to be 1. So I'm just going to insert 1s. And it doesn't really matter where we insert it, because we're going to sort this list. So all the points are nicely sorted. So we can sort this list. And I'm just going to use a create set component. And this will make sure that there's no duplicate values. It's not completely necessary, but just in case. And the final step would be to use this set of numbers that we have to evaluate our curve. And this time we are going to use evaluate curve, which requires parameters. So all the way to the beginning, our original curves. and then the set input. So if I turn everything off, it should have worked. Cross your fingers. Let me just turn everything off. And our cursor can use. So if I should set this thing to 1, no points are curled. But if I decrease this value, supposedly the ones that are close enough, they should be, removed from our list. And that's exactly what's happening right now. So you have a bit more control here on the end. If you think the bay is getting a little bit too small, maybe right now it's not needed because this is not that small of a distance. But let's say if you use another value, let's say use, I don't know, like a value like this, you see that here we have, really tiny distance. And then like this value comes in handy to kind of kill out those points, right? Next up is creating those jagged facade outlines. And for that, we're going to use the points and the tangent from the evaluate curve output. And the tangents are vectors. So the first thing we're going to do is create a plane on top of those points. So a regular XY plane is fine. Just like this. So right now on all those points we have, an XY plane. But as you can see, they're all orientated the same direction, right? It doesn't matter how the facade curves kind of move. That's not what I want. I want to align those planes according to those curves. Now there's a nice component called align planes. And there's 2 align planes. This one, which uses, I think, a guide plane to do that. But we want to use the other one, this one, align plane, using a guide vector. And as you might have guessed, these are the vectors we're going to use to align them. And now supposedly, if I turn these ones off, you can see that all my planes right now are nicely aligned according to all the curves, right? So here they nicely bend around the corner. Because it's a plane, we have the individual XY axes. So to get those, we can use the deconstruct plane component, which is here. And I think it's the Y, because we want the axis that points inwards, right? So I think with an SDL, we can show you. So if I turn off the planes, you see right now that we have a line pointing inwards perpendicular to the facade outline curves. And that's exactly what we want, because in the end, we're going to draw the jagged lines like this, from like it goes inwards a little, goes to the next point inwards, etc. Gonna have our points, and then this is going to be our vector. But we're not gonna move all the points. One point's gonna stay on the facade. The other point basically is gonna go inwards. So we have to shift our point list into 2 lists, basically. One that has the first one removed and another list that has the last one removed. So we're gonna use a shift list component. This is a very helpful component. And make sure you set the rep values to false. So I'm just going to use a toggle to make it clear for that. And the offset would be first -1, which would remove the last one. And another one that is +1. Yeah, and this one removed the first list, just like this. And I'm going to do the same for the vectors. But the vectors, because we're just going to use one point that's moving, we're just going to use the -1 list, just like this. This is the one we're going to be moving using this list of vectors. So I would just need an amplitude to give this vector a certain length, like this. So for now, we're just going to use a fixed number. Later on, we'll change this. So let me just insert a number slider with 5 meters for now. And then the move component, these are the points we're going to move using this distance. And then I want to weave this list and this list back again together. And there's a nice component which is called weave, which does exactly that. It weaves 2 lists together, or multiple lists, depending if you add multiple here, depending on the pattern. The pattern, the default is already set to 0, 1. So it will weave one item from 0, one item from 1, one item from 0, etc. until both of the lists are done. This one goes in here and this one goes in here. And if I turn everything off, supposedly if we now use a polyline to connect all those points again, So now we have more or less what we're after, right? We have a jagged facade line. The only thing is it looks nothing like we want to do. First of all, what I want to do is create an offset that's a bit more dynamic. Instead of having, like here we have 5 right now, 5 units or 5 meters as our offset. I want to kind of start with a big value, that could be 5, but then I want to kind of have it decrease as we go along the facade until it reaches here, which would be, 0. Let's do that first. And we can do that here. If I move everything a bit back. So first I'm going to get, again, 3 statistics because I want to know how many items are per branch. In the L, that one will tell me. And let me also set the display to draw full name so we know what's happening a bit better for you guys, what's required. So the length, that's the one I'm concerned with. And then I just want to generate some numbers. And the length of that list of numbers would be exactly the length that it tells me here. So I want to create 18 lists of 11 numbers from 0 to 1. So we're going to use a range component for that, which has a domain input, which is already set to 0 to 1, which is great. And then the steps, that would be the lengths from these guys. Now be careful because we're not going to get 11 numbers, but we get 11 steps, which means 12 numbers. It's the same if you divide a curve and you want to have 11 segments, you're going to get 12 division points. So to remedy that, we can simply use an expression in the input and say x minus 1. So now supposedly we should get 11 numbers. And then I want to remap these numbers. And also, when a number gets really small, I basically want it to, instead of offsetting like a really, really tiny amount, I just want it to be not offsetting at all. Basically, a little bit what we did here, like a fail-safe that, hey, if a number is so tiny or it gets too close, the values get a bit funky. We can use like a fail-safe like this to kind of snap it to 1. So we're going to use the same expression for that. And we'll just say if this time if x is bigger than y, it should be 1. And if not, just output x. These are our numbers. And then another number slider. Let's set it to, 0.8 or something like that. Later on, we can fine tune it. So now if I go to panel, you see that we have a list. And here you see that, hey, if it's above a certain number, just output 1, like depending on what you insert here. Okay, source is 0 to 1. And then the target, that's going to be the actual offsets that we're going to be using. So I want to be offsetting, let's use a slider from 0 to 10. Let's say, 6 meters. And then we're going to start at 0. I think that's fair. Also with these guys, you have to shift them 1 back. It's a bit cluttering these lines, but it's okay. Just like this. And now instead of using a fixed value here, we can use this list. So now if I go again to my polyline, you see that they start big and then they slowly decrease until the end. The only thing is, they start on this side and I want to start them on the other side. So we just have to flip these values around. So I'm just going to say 6 here and then, 0 at the other side. And just to clarify what this thing did, like if I set it to, 1, we get this really tiny offsets here. But with this thing, we can remedy that. Like here you see that it's snapped to the actual facade outline. We have a bit more control over those jagged lines. So as you can see, we're almost there. The only thing I don't like is that it exactly offsets perpendicular to the facade. Like what would be ideally if you would rotate this curve or this vector just a little bit, so this angle is not that sharp. And we can do that simply by adding a rotate plane in between here. So we rotate the plane a little bit manually using the rotate plane component, which is this one. It just rotates a plane with an angle. So the input is in radians. but I think it's a bit more clear if you use degrees. So let me just use a slider from 0 to 90. And let's try 20 degrees. And let's see how it turns out now. That's the wrong side. So you have to go to negative. So use some negative numbers. More or less like this. So let's use 20. Why not? So we're getting pretty close to the end result. And here you can, increase or decrease how much, those balconies are set inwards. And as well, the cutoff on this side, right? So if you lower this amount, you see that. Like from here, if I select my polylines, from here it's just like a straight line. So you avoid these really tiny, offsets. So in this last part, we're going to transform our 2D line work into 3D geometry, basically transform our curves into some surfaces and poly surfaces. So let's do that. And we're going to start on a new line because I've been creating everything linearly and the definition gets a bit stretched. So what I like to do is just finish at a point which has some important geometry, like here right now, our jagged curve facades, and set the wire to hidden and just drag this one to a new line somewhere here. And then here we can start again with our definition. So these are our facade jagged curves. And also we need the floor-to-floor heights. So we know how much we need to extrude these curves. So there's a couple of ways of transforming this into an actual surface. First of all, we need to close those curves, but I want to create more or less the outline of the building as well. So I think a quick way to do that is to get the bounding box per curve. The component for that is called bounding box. And make sure you set it per object. So per curve, it's going to create this bounding box. And we just need the outline of that bounding box. So I need to explode that B-wrap, which is called deconstruct for some reason in Grasshopper. And I'm just interested in this face, which is this one. And what I want is, because these ones are square surfaces, but I want to kind of trim off that jagged part basically. So there's a component called surface split. This one. So our surfaces would be those bounding faces we just created, and then the curves would be those jagged lines. So let me just do it like this. Let me turn these guys off. So now we have the fragments. So supposedly should be a couple of fragments depending on how those jagged lines basically behave. But I just want to have the biggest one. So we need to sort them using their area, using the sort list component. Then the values I want to sort with are those fragments. So these guys, and then I want to get the biggest one. So I could reverse this list like this. So instead of getting the smallest one, I'm retrieving the biggest value. And supposedly that's the surface that we're after, right? Those facade floors. So that's one. And the next thing I want, we can already do that as well, is just to extrude these facades. So we get the actual facade, like a solid surface. So the base would be our curves. Well, let me just copy this so we don't get spaghetti lines. And the direction is the C. And then of course our floor-to-floor heights, we go in here. Supposedly, so we have 18. This should also be 18. Don't forget to graft it. Nice. So now we have all of our facade elements, like the actual facade solid, and we have our floors. But we're not done yet because, as you can see, the floors are not exactly how we want them, because the balconies are still void. If I bake them, maybe it's a bit more clear. In Rhino, let me turn this off. So as you can see, like, yes, we have the floors, but we're missing the balconies, which are kind of important. Let me Control C. So let's see how we can remedy that. So what is needed is basically, it needs to get the information from the floor below to kind of know how much it needs to add to the floor in the form of the balconies. So what we can do is use the floor outlines and move these guys up to their next floor, basically. So these guys, geometry, then motion would again be from floor to floor height. So we have 18, these are also 18, nice. So now I have moved basically all those floors one up, except this one doesn't have double because there's no floor below it. And the same for the roof, right? Because it's the last one. But these ones, like the combination of these ones, that's actually what I want to achieve, right? And there's a component that does that for us, which is a very helpful component as well. And it's under intersection tab and then in the shapes and then region union. It would be this one and this one. But the problem is that we have to rearrange the branching numbering a little bit, because these guys are numbered between 0 and 17, so 18 branches, and these ones as well. But I want to renumber these guys. Instead of starting at 0, I want to start these guys at 1. If I join them together, the branching also works. So there's a couple of ways to do this, but I think the quickest one and the easiest way to do this is using the path mapper, which is this guy. So just connect it, right click on it and just select create null mapping. So A is our original numbering and I just want to do A plus 1 basically. So if I show you with a param viewer what happened, you see that instead of starting at 0, we just start at 1. The geometry itself didn't change. I just changed the organization a little bit. Like if I put this one next to it, like this one starts counting at 0 until 17, this one 1 to 18. And now supposedly, if I add them together using a merge component, and then I can use another param viewer, we nicely have the organization I want. So we have the ground floor, which only has one element, which is correct because there's no floor below it, so it doesn't have to adjust its outline. But then we have 2 items for the floors that are continuing. And those are the ones exactly that I want to get the union from, all the way to the top. And the last floor again, 18, only has 1. That's correct because it's the roof. So I can connect this one here. And now if we go again, looking at the result, you see that we have the union of those 2 surfaces, right? So we also include all these balconies. These are the floor outlines. And these are the facades. And I can just boundary surface this guy. So we get the actual surface. We're almost done. If I just turn off some geometry. So now we have the floor outlines with the balconies. So that's really nice. The cool thing is, if we just want to get these balconies, you can use another component from the shape, intersection shape panel. So it's this one and this one. And I think it's the region difference. So let's see what happens. It's precisely the ones that we don't want. These are the bottom parts, basically. So I think if we flip these guys around like this, yeah. Now we get just the balconies, right? So that's really nice as well. If you just want to have those surfaces for the balconies. So I'm just going to boundary surface. So these would be balconies. These would be floors with last one roof. And just with the facade like we have here, we have just the front panel of the facade. But let's say you want to also create these parts of the facade as well, just to have a solid volume. We can do that as well. And I think the most easiest way is to get the bounding box. Just select the edges from that guy. So it would be list item. So it's not this one. Also not that one. It's this one and that one, if I say that correct. No, it's 1 and 2. Wait, let me see. This one and this one, yeah. So we can just hold your shift so we can add them both here. This is the back facade basically. If I'm correct with this, the ordering of the benches, yeah, we can use the same floor to floor heights and the unit factor as well. So we just have these guys as well. So let me just put everything here to the end so we know what are the important geometries that are being outputted. So we have this guy. So I'm just gonna call this jagged facade surface. I think this is one item. These are two. Yeah, we can join these together. Beaver join. And this is then the back facade. It's a bit of a crude word, but it's just for us to know what we're outputting. So if you're gonna bake it to Rhino or start playing with it, you know what it is. So this is the end result right now. We just have to, if I turn this guys off, the only thing that's a bit off, if you remember the photos, is that here it kind of curves inwards, and I wanted to kind of start curving straight. So now we have to start playing around a little bit with these curves. We can just start rotating this thing a little bit. Let's see what happens. All right, internalize the curves. Excuse me, let me just do that again. And I have to flip them around again, apparently. And I have to, instead of flipping them here, like this, yeah. So we have them almost correct. I can maybe rotate it a little bit more. Let's see. Like this. So now it's looking a bit more closer to the building. And we can adjust maybe the curve like a little bit better, because now it has a curve in the beginning and then it's almost more or less straight. So let's see if we can adjust it a little bit using the, the bulge factor. I mean, this is just for you to get a better result. I mean, this is kind of a tedious process, but that's why we set it up, parametrically. Something like this, right? So you have to manually kind of, rotate this thing a little bit so you get it as best as you can, or however you want it to look. Yeah, something like this, right? So now we have everything set up. So we have our facades, our curve outlines, our balconies even. So now you can, if you want to, you can start baking it to Rhino and start designing, these balconies. You even have the actual size of those balconies, so you can even measure them in Grasshopper itself, just to check if they're not too small. This is here, if they're really small. Remember, you can play, which value was it? The fail-safes that you've built in. So here you can lower this number, and supposedly they start disappearing. So that's how you fine-tune your facade a little bit. That was also the end of this video. I hope you find it exciting. I hope it can help you on your way to know how to set up a facade, slice your building at the right heights, and maybe throw in some parametric logic for your windows, for your balconies. I hope it was helpful for you to know like some tips and tricks how to set it up proper. Hey everyone, thank you so much for sticking with me through this exercise. I hope you found it helpful and that you're feeling more confident in applying these parametric modeling techniques to your own projects. This exercise was quite in-depth, so if any parts feel challenging, don't worry, you're not alone. At Think Parametric we have resources to help you, no matter your skill level, whether you're just starting out or already on an advanced level. Our courses cover everything from Rhino and Grasshopper basics to advanced parametric workflows, computational design, and much more. If you're looking to deepen your understanding of parametric modeling or explore other architectural technology skills, Think Parametric is the perfect place. We've designed our platform to be accessible, structured, and practical, helping architects and designers upskill effectively. If you enjoyed this video and want to keep improving, I invite you to explore our full course library at thinkparametric.com. Let me know in the comments below if there are any particular parts you found tricky or if you have any questions. I'd love to help you out. And finally, we have more great content for you to explore. I highly recommend checking out our video on Google Sheets to Grasshopper interoperability or our guide to the 7 must-have plugins for Grasshopper. Be sure to give them a watch. Thanks again for watching, and I hope to see you in the next one.